Hello and welcome to the video guide for the Smartphone Apps Data Management Project by the Big Data Management and Analytics Lab at UTD. This is an effort to facilitate the virtual laboratory and curriculum development for secure mobile computing. This project is funded by NSF, and it is under the supervision of Professor Lateef Khan. This video will go over the project and its online applications. The Smartphone Apps Data Management Project explores the idea of performing traffic analysis on apps. With the recent emergence of mobile platforms capable of executing complex software and the rise of such platforms in sensitive domains such as banking, military operations, law enforcement, etc., user privacy and data security have become major concerns. The focus of this project is to identify an app by listening to its encrypted network traffic. We call this app fingerprinting. Here we see an overview of app fingerprinting. An attacker passively gathers encrypted packets, extracts features, and then uses data analytics and machine learning to predict the name of the app. In this way, the attacker can gain information that negatively affects the peace and security of the end users or the general population at large. It is important to note that the app server IP address cannot be used to reveal the name of the app, as multiple apps may be hosted on the same cloud server with the same IP. The web application tool introduced in this video has two objectives: mobile dynamic analysis and data analytics. So the first part of the project is dynamic analysis, which is performed through data collection. We build a dataset by executing 2,000 randomly selected Android financial apps and capture their network traffic. We used a Samsung Galaxy S running Android 4.3.1, but for the purposes of the web application, we demo this using an Android emulator. Each trace is collected over a 30-second period using a mirroring switch at the wireless router. The second part is data analytics. This involves using the traces collected in dynamic analysis and performing feature extraction to train a classifier that predicts an app. Once the classifier is fully trained, we can feed it an app's network traffic and it should accurately identify the app. Alright, so when you first access the website, a login screen will appear. If you already have an account, go ahead and log in. If you do not, we're going to go through the steps to create an account right now. The first thing you do is click this Create an Account link in the bottom of the sign-in box. Here you will enter all the information that is listed below. So your first name, your last name, a valid phone number, and make sure you also enter a valid email, as you will need this to complete your account creation process. Enter a username and a password that you will use to access your account later. And make sure your passwords are the same, otherwise the process won't be completed. Hit the submit button when you're done. If there are any problems, it'll let you know. In this situation, I need to fix my username. Can't have any periods. Once the creation is started, it'll let you know, and you need to access your email account to complete it. So go to your email account. A code will be emailed to you from the Big Data Management and Analytics Lab. Copy and paste that code into this box, and your account has now been created. Use the username and password you just made to log into the system now. Alright, so when you first access the website, this is what loads. There's a series of tabs that contain everything about the project. The tab that loads is the Dynamic Analysis tab, which is phase 1 of the project. The Data Analytics tab will cover phase 2 of the project. There's these two other tabs at the end. Documentation has some helpful links. These two are relevant papers, and the user manual is a step-by-step guide on how to use the website. These can provide some more background information if you want it regarding the project. The About tab has some more information about the project, the lab that conducted it, and there's an email address down here to contact us if you need to. The Download tab over here has a mechanism to download the results of the tests that we run, and I'll go into this more later. So the Data Collection Dynamic Analysis tab, as I said, hosts the first part of the project. Here we have a drop-down menu to select apps to run and capture network traffic from. To select an app, select it in the drop-down menu and hit the Add button. You can select more than one app, but if you try to select the same app twice, it won't work. You can see the apps you've selected in this table down here. When you're done selecting the apps you want, go ahead and click the Collect button, and a message will appear letting you know the tests have begun. So the process can be seen on the emulator screen right here. All website functions will be unavailable, by the way, while the tests are running, so you can't hit any other button or go to any other tab. So essentially what's going to be happening is that the list of apps that you create, going through that one by one, the phone will install the app, then it'll open it for 30 seconds and collect the network traces that are in the background, and then it'll uninstall the app. And this uninstall process occurs simply to prevent any background noise that could affect the results of the tests. So here we can see, as the process occurs, we'll be able to see, right now the first app is being installed, and then we'll see the app open up, and then we'll see it close, and in that point it's being uninstalled, and then the next app will occur. So this is the first app right here. Again, these are all financial apps. There are 2,000 apps that are that we are accessing, and these are all going to be financial apps. This is the process we use to build the data set. So each of our apps each of the 2,000 apps have a 30-second trace that we collected, and this process right here on the website simply emulates what we created already. So the trace is being collected right now. And then in a few seconds, the app will close and it will be uninstalled. And there it goes. And this will happen for the second app or however many apps you choose. So I'm just going to go ahead and cut to the part where the tests are complete. The process is complete. A pop-up window will appear letting you know. At this point, if you want the data collected, then go to the the Download tab, and select the date and time of the tests you just ran, and then click the Download button. This will download as any other file or folder does on your computer, and if you hit this, you'll be able to follow the file path to the results. Now this completes phase 1. The dynamic analysis part we just completed demoed how we collected traces to make our own data set. Features such as packet size, time, etc. are extracted from these traces and are used alongside machine learning techniques to train a classifier. Once the classifier is trained, we can use it to identify an app from its network traffic. This process occurs in the second phase, or the data analytics phase. So here we emulate the second phase by evaluating the effect of various machine learning algorithms with different feature extraction techniques. These are all parameters for the tests we complete, and we define everything from the number of websites to take into account to the defenses the traffic has. So I'm going to go through each one of these 9 parameters and explain them a bit more. So there are 10 unique classifiers that can be selected in the classifier drop-down menu. For example, Penchenko utilizes a support vector machine and considers feature stealing with packet length, order, and size. Another classifier is the dir variable ngram, which implements naive Bayes with trace time, burst time, and size. The newest classifier incorporated is the bidirectional classifier that adds biburst features. There's also a series of defenses you can pick from. The pad to MTU defense, for example, pads the total packet size to the maximum transmission unit. Another defense, direct target sampling, modifies the appearance packet length distribution, while the traffic morphing defense utilizes convex optimization to distort the order in which packets are sent. Since this project is only dealing with app fingerprinting at the moment, the dataset we select is the Android apps dataset. Now, if you select the bidirectional classifier, then you have an option to pick from features in this. You can multi-select features by holding down the control button on your keyboard and selecting the features you want to take into account. Remember, this is only available with bidirectional classifiers, and the other ones have preset features. The number of apps, which is first to the total number of applications selected, may range from 0 to 2,000, as this is the number of apps total in the dataset. I'm going to go with 10. The bucket size is the size of the privacy set and can range from 0 to the number of apps. So in this situation, it has to be less than 10. I'm going to go with 4. The number of trials denotes the number of trials the experiment will run, and this is limited to 100 trials. The number of training instances is the number of training traces used per experiment, and the number of testing instances is the number of testing traces used for each experiment. These together need to add up to 20. So in this situation, 16 plus 4 is 20. Now, if for whatever reason you fill out all the fields but you've missed one and you try to run the tests, it'll let you know. So I'm going to fix the defense and I'm going to run the tests. Once the tests start running, a message will appear letting you know. With the parameters are set, the test is randomly selected 10 apps from the apps dataset, applied these defenses, and evaluated it under the bidirectional classifier with these features. So now that the test is done, I'm going to hit OK, and I can get these results by going to the Download tab and selecting the Output folder and downloading again as any other file or folder would download. So this pretty much wraps up the Smartphone Apps Data Management project. Again, we had phase 1 in this, which is emulating data collection, phase 2 in data analytics, which is the actual website app fingerprinting. Documentation is in here, and there's a couple of helpful links again. The About tab has a way to contact us, and if you have any questions, go ahead and email us at this email, and we'll get back to you as soon as possible.